This is the Eachine Tyro 119 quadcopter. But it isn't yet. This is just a box of parts. But we're going to take this box of parts and we're going to build it into a quadcopter from start to finish. I'm Joshua Bardwell, and you're going to learn something today. If you're new here, and I hope a lot of you are new here, because I hope a lot of people are going to be following along with this build series as their very first quadcopter build. If you're new here, nice to meet you. I love helping beginners get over the learning curve of everything in between. I'd like to fly a quadcopter to, oh, now I actually am flying a quadcopter. There's so much that you have to go through to get from point A to point B. And you can find a lot of that stuff on my channel. But every so often, I like to do a series where I take all of that stuff and I put it all in one place. And that's what this playlist is. Down in the video description, there's a link to this playlist. This is video number 1. And we're just going to keep going. We're going to build the quadcopter. We're going to put it all together. We're going to configure it. We're going to do everything that a total beginner needs to know how to do to get from pile of parts to a quadcopter that you can fly. The quadcopter that we're going to build today is the Eachine Tyro 119. And let me tell you why I picked this one, because the Eachine Tyro series of quads are very inexpensive. And they actually provide pretty good value for money. They're cheap and they're not quite crap, but they're not spectacular either. And when I did my very first build series a couple years ago, I handpicked every part that I wanted to be in it. It came in around $220, $240. This one is much cheaper than that. Even though I think this is not as good a quadcopter as the one I handpicked the last time, the problem we ran into was that we were always out of stock of some part. And so nobody could ever freaking buy the thing. So in this case, I've gone with a pre-made kit, the Eachine Tyro 119. Eachine's going to keep it in stock. You will be able to buy it. You will be able to build it. And even though I might wish that it were a little better in some ways, it's still pretty good and it's still a great choice. And the fact that you can actually get it will make up for the fact that maybe, well, it's cheaper too. So anyway, that's where we're going with the Tyro 119. The other thing that's really exciting about the Tyro 119 is it is a GPS capable quad. So if you want to, you can fly it like a racing or freestyle acro quad, but I'm also going to show you in this playlist how to set it up to do things like GPS return to home and so forth. We're going to set it up with both Betaflight firmware for racing or iNav firmware if you want something a little bit more like a DJI. So let's get started. And we're going to start with the pieces of the frame. This here is the bottom plate. This piece might be called the X plate. These are the arms, and this is the top plate. We'll set the top plate aside for now. Oh, and these are the camera side plates. We don't need those. And we'll set the arms inside. And we're going to start with this, the bottom plate. These little guys here are known as press nuts, and the way they work is that they are going to press into these larger holes on the bottom plate. So we're going to go ahead and press these in here. That's why they're called press nuts. They will take a little bit of pushing to get to go in, but you should be able to get them to go. You see how that's not really flush? You should be able to get them to go completely flush. And we're going to put in 4 of those. 1, 2, 3, 4. Next, we're going to get 4 of the longest screws in the hardware kit. So the next thing we're going to do is we're going to take the bottom plate and an arm, and we're going to put that screw up through the bottom plate as such. And then we're going to take the arm, and the arm needs to go the right way around. The arm is going to go like this, not like that. Like so. And then we'll take the bottom plate, and again, remember, the press nuts need to be on the top of the bottom plate, so it needs to be like this. So the screw is pulling the press nut down into the bottom plate, as opposed to like this, where the screw will be pulling it out. And we're just going to get that started. Okay. And we're going to do that with the other 4 arms. Not 3, the other 3 arms. Now that we've got those 4 arms loosely installed and facing the correct direction, we're going to take 4 more screws of the same length and we'll insert them in the second hole. And these guys are going to get these little nylock nuts. One on each one. Now to cinch this down, we're going to use this 2mm driver. Strongly recommend you have a 2mm driver, a 2.5mm driver, and a 1.5mm driver. These are very, very commonly used sizes on quads. I have a link to a toolkit you may consider getting on my website, fpvknowitall.com. There's a section there for tools. Sorry, I got confused there for a minute because I saw that I had accidentally picked an incorrect length of screw. So there are 2 different lengths of screw here. The longest one goes in the press nuts. The slightly shorter one goes here on these nuts. This is a 5.5mm nut driver, very useful for these little nuts. And here's what we got so far. Now you might wonder, why are these press nuts sticking through? And the answer is that we're going to take these little standoffs and we're going to put them one on each of the press nuts. What I'd like to do next is get out the motors and install the motors. Now the motors come in 2 bags of 2 motors each, and the reason for that is that one of these motors is counterclockwise and the other is going to be clockwise. Notice that the second motor in the bag appears not to be marked at all, but the thing you need to know is that that refers to the threading on the motor nut. 2 of these motors are going to have standard threaded nuts and 2 are going to have reverse threaded. And the idea there is that if the prop like hits a tree or something and the motor stops suddenly, that if the threading on the nut is correct, then the nut will tighten down instead of loosening up. The motors can spin either direction, first of all, and many builders just use standard threads because it's more difficult to find reverse threaded lock nuts. We're going to do this one like Eachine ships it, but don't let that confuse you. The fact that one motor is counterclockwise, one's clockwise. Brushless motors can spin either direction. It just refers to the threading. And frankly, there's a thing called turtle mode, where if the quad is upside down, the motors reverse themselves and it can push it up off the ground and flip it over. So you can't even assume that the motors are always going to be spinning one direction or the other. Most of the time what people do is they'll just use a good lock nut with a nylon insert that's called a nylock nut, and then the prop won't come off. It'll be fine. But since that's what Eachine has shipped us, that's what we're going to do. Standard way that Betaflight works is this motor will be spinning this direction, so we want that to tighten. Yeah, so we're going to have a clockwise here, and a clockwise here, and a counterclockwise here, and a counterclockwise here. Clockwise on the front right and back left, counterclockwise on the front left and the back right. Now you should have a bunch of these little screws that stick out just that far. Those are your motor screws. And we're going to use those to install the motor. And the motor is going to get installed with the wires coming off this direction so they run down the arm. And I suggest you just leave them slightly loose until they're all 3 started, and then tighten them down. So it looks like these arms have been drilled with, well, not quite oval holes, slightly wide holes, I guess, because some motors have different size bases. They want you to be able to use this frame with other motors, I guess. So if you put the screw in on the outer hole, it's not going to work right. It needs to be on the inner. There you go, like so. Now let me warn you, it's really important that you not use the incorrect length of screw. If the screw is too long, it will protrude up through the base and it will touch these windings and damage the windings, and that can basically just destroy the motor. So as you're installing the screws, just make sure that you haven't accidentally picked up too long of a screw and damaged the motor. So here we've got our 2 clockwise motors installed on the front right and the back left. And I was wondering, I forgot to tell you guys how to identify the Oh no, I've got it backwards. Ah! I was going to say, how do you tell the front from the back? Well, this is the front. I can tell because I recognize that these cutouts are for the camera plate. But I had the quad turned around. Turns out it still works. It's the diagonal, so even if you accidentally have the quad turned around, front right and back left are still clockwise, and front left and back right are still counterclockwise. It will matter eventually, but at least for the motors, you can get away with making that mistake. Next, we're going to deal with this guy here. This is the Electronic Speed Controller, or ESC. And basically, the way that brushless motors work, and that's the kind of motors we've got, is they have to have electricity pushed through their wires in a very specific way, and then they spin, and everything's wonderful. The point of an ESC is to make the motor spin. There you go. Now, this type of ESC is known as a 4-in-1 ESC because there are 4 motors, so you need 4 ESCs, and this is all 4 of these ESCs on one board. And that is nice because it makes the wiring a little simpler. It saves you a few steps. It is kind of a pain, though, because if you blow one of these ESCs, you have to replace all 4, although this thing probably isn't that freaking expensive if I know Eachine. So what we're going to do is we now definitely do need to identify the front and back of the quad. And the front is going to be this wider section with these 2 kind of slots here and these sticky outy nubs here. The back is this thinner section with 1, 2, 3, 4 cutouts here. And we're going to turn the quad facing forward, and we're going to turn the ESC facing backward. And we're going to set it down on the standoffs. Now, the good news is that they have cut these wires to just about the right length. That's very convenient of them. And we're going to take each of the 3 wires coming off of the motor, and they're going to get soldered to each of the 3 motor outputs. So here's 1, 2, 3 motor outputs for the back left motor, 1, 2, 3 for the front right, 1, 2, 3 for, front left, 1, 2, 3 for the front right, and 1, 2, 3 for the back right. And this is the point where a whole lot of people are going to have some heartache, because soldering, you have to be able to solder, or solder if you're from anywhere but America, basically. You have to be able to solder to put a quad together, and if you didn't set out to learn how to solder, you may be like, well, I just want to fly a quad. I'm really sorry. You have to stop now, and you have to go learn to solder if you don't already know how to solder. If you do know how to solder because you've done electronics before, good for you. You're clear to proceed. I'm going to put a link in the video description to a good soldering tutorial. There are a lot of good tutorials out there on YouTube, but I don't suggest that you just charge blithely ahead and do your best, because you can damage the equipment. You can build a quad that falls out of the air. It is really, really worth taking a couple hours out of your day and just practicing soldering on a piece of practice board or something, and not practicing on your expensive equipment. This is not a soldering tutorial. Like, I went back and forth on whether I was going to try to do a soldering tutorial, because this is about how to build a quad, and we got to assume you bring some things to the table. If you don't already know how to solder, I strongly recommend you pause, you learn to solder, spend just a couple hours practicing, and then come back. We're going to proceed though. Now for these pads, I'm going to suggest we put our soldering iron at a little bit higher temperature, but not super high. How about 750 Fahrenheit? And my editor can put whatever that is in Celsius for the rest of the world right here on screen. 750 Fahrenheit though. And what we're going to do, I think, is we're going to start with this outermost wire, and we're just going to work 1, 2, 3 across. There are 3 wires. We're going to take that outermost wire and we're going to kind of give it a 90-degree bend, and then push it up through the bottom here of the ESC. Now I'm going to strongly recommend that you use some liquid electrical flux, or maybe if you have paste flux, if you prefer that. Flux makes soldering much easier, and I'm just going to dab some of that on all the pads that we're going to be soldering, including these big pads here, which we'll get to in a minute. I'm just going to apply that to all of the pads. The solder that I'm using is 6040 rosin core leaded solder. Strongly recommend, especially that beginners use leaded solder. It's much easier to solder with. The risk of lead exposure is very, very small. You're not using it that much. Don't eat it and you'll be fine. 6337 alloy is better, but not everybody can get a hold of it. Soldering iron's at 750. I have fluxed the joint, and we're just going to go ahead and solder this wire down. Hello, sir. If you don't mind, thank you. Okay. Now I'm going to take the middle wire from the motor, and we're going to do the same thing. We're going to bend it 90 degrees, and we're going to go to the second pad. And we're going to take the third wire and do the same thing. Now here are my solder joints, and these are not world-class solder joints, but I'm not ashamed to put my name on them. They are shiny, silver, smooth surface. If you have craggy, dull gray solder joints, if it's not a smooth surface, that means things didn't go right. Maybe your iron was too cold. Maybe you didn't get enough heat into the pad. There are various things that could go wrong, and if your joints don't look at least a little bit like this, then you need to go back and learn how to solder. Or charge ahead. It's your quadcopter, but the number one mistake I see people making in their first build is not taking the time to become at least semi-proficient at soldering before they go, and it makes a lot of problems. Let's proceed. Now, another question you may be asking is, how did I know which wire went to which of these pads? It turns out with brushless motors, it doesn't matter. It's not like there's a plus and a minus and a signal, or an A, a B, and a C, although sometimes you do see motors and ESCs labeled that way. Brushless motors, if you wire the wires to the ESC one way, the motor spins clockwise. If you flip any two of those wires with each other, the motor spins counterclockwise. There's no wrong way to wire it up. It's just that some of the ways you wire it up will make it spin one way, and some of the ways will make it spin the other way. And so the question you might then ask is, well, which way is it going to spin? Because yes, it does matter. Some of these motors need to spin clockwise, and some need to spin counterclockwise, depending on their position, where front left, front right, back left, back right. And the answer is, I don't care, because we can change that later in software. So what I always do is, it's not really possible to predict which way the motor will spin unless you've built a whole bunch of quads with this exact ESC and these exact motors. Maybe then you would already know, but I don't know, and I don't care. I'm just going to wire these straight through to the ESC, and then later, if I need to switch the motor direction, I can do it in software. So I'm going to do the same thing with this one. I'm going to take wires 1, 2, 3 and solder them to 1, 2, 3 here. And I'm going to keep doing the same thing with the other 3 motors. I'll pause the recording and I'll come back when that's done. Well, okay, we're back, and I have soldered down all 4 of the motors. Another thing you'll see here is that as I worked my way around, I started installing additional standoffs on top here, and that just helps hold the ESC in place. I don't like to install those while I'm soldering because I will touch them with the soldering iron and melt them, and they'll just be in the way. But now, well, we're not quite done soldering, but we'll install those to get the ESC held down. Then what I like to do is I'm going to neaten these wires up and try to get them out of the way. And what I'm going to do is I'm just going to kind of push them to the back and kind of, what I'd like to do is actually have them run on the inside of the arm. And the reason for that is that the propeller is going to spin like this. Okay? It's going to spin like this. And if the propeller gets bent and strikes the arm, it can cut the wires if the wires are on top of the arm, as they often are. But if you put the wires on the front of the arm, or rather the back of the arm, the inside of the arm, if you will, then it keeps them out of the way of the props, and that's how I like to do it. Now, there's a lot of different ways that you can accomplish this. I like to just use some red electrical tape. Sometimes It even is seen as my signature red electrical tape because I do it so much. Some people think it looks really trashy. Whatever. Don't do it if you don't like it. But so we're gonna just, yeah, just like that. Boom. In fact, I got more than I need. And we don't want any tension on these joints. You can see there's plenty of wire there to have just a little slack. We don't want any tension on the joint, and we could even try kind of pull just a little away from the motor to make sure that there's no tension on that joint. What I like to do is I'll wrap it loosely here, and then I'll kind of pinch the wires so they stay on the front of the arm, and I'll kind of just snug it down while keeping the wires on the front of the arm. So we got the wires now run on the inside, assuming standard prop direction where the props are rotating toward the center line of the quad. So the props will be coming this direction and they will strike here, or the props would be coming from this direction and they would strike here and they would not hit the wires. That also helps protect the wires in a frontal impact. If the quad is flying and it crashes into something, the wire won't take the hit. Next, we're going to get out the battery connector. It's in a bag with some other plugs that we're going to probably use later. We'll set those aside for now, and we'll get out the battery connector. We'll do the same thing here. We'll just give these guys a little bit of a right angle turn, and we're going to solder to here. Now, it's critical that you get this right. Minus, plus, black, red. Minus is black, plus is red. I can see I've twisted these the wrong way. I got to turn these over so that they'll go in the right holes. Okay, and we're going to just push these up from the bottom, just like we did with the motor wires. Might need to use my handy dandy tweezers or forceps or whatever if you've got them. Okay, perfect. And you'll notice this capacitor is already pre-installed. That's very nice of them to do that for us. And don't forget that I added some liquid flux. Now for this one, we're going to want, I crank my iron to the max because especially this ground pad is very heavy. It takes a lot of heat, and I crank it up to 850. There are pros out there who say that that's way too hot. You shouldn't need to run that hot. And I say, well, yeah. If you don't have a good soldering iron, or if your soldering iron is cold, if the tip is oxidized, you're going to struggle with this. Let me show you how I do it, and we'll see. If it doesn't go smoothly, it probably points to an issue with your iron, or maybe the solder that you're using. Let's let this get up to 850, and I'm just going to apply heat here. I'm using a relatively heavy tip, a relatively heavy chisel tip, and we're going to just apply heat and start to feed in some solder. And as the pad heats up, the solder will flow all the way out to the edge of the pad. And that is just how simple it should be. If it doesn't go like that, it's probably your equipment or your setup, not necessarily your technique. Most people, most beginners who are having trouble have bad equipment and bad technique. But if you have good technique, you can make up for bad equipment somewhat. But if you don't have good technique, you need to have good equipment to, you know, make things work in your favor. I'm trying to touch both the pad and the wire at the same time and just feed in enough liquid. Come on now, what are we doing here? Feed in enough solder and watch it flow to the edge of the pad, just like so. And again, notice we have nice shiny silver smooth joints with solder flowed all the way to the edges of the pad. No bridges. We'll go back and we'll double check these motor connections. There's no bridging between these outputs. There's no solder blobbed up onto the FETs here. We don't have any connection between, like these little legs here and the pads. None of that. It is all clean, distinct. That's how you want it to be. If you do have any problems like that, like you've accidentally bridged some of these, you're going to need to clean that up before you go. Like if you do accidentally bridge one, you can just take a hot iron and kind of just swipe and should pull it away. I don't know, maybe call a friend who's really good at soldering. Do you have one of those? You don't have a friend that's like super good at soldering? We've all got that friend, right? No. Okay. The next thing we're going to do is we're going to take this little wire here, and it is going to plug into this socket here on the front of the ESC. Doesn't matter which side you plug in. It is keyed, so it will go in only one way. If you try and flip it upside down, it won't go in. So if you're having trouble pushing it in, it may be that you need to flip it upside down. Be careful. There you go. Mine went straight in. Be careful that you don't accidentally bend one of the little pins. If one of the little pins isn't quite straight and you shove this in, you'll bend the pin. If there's any real like resistance, it should go in pretty smoothly and easily. Hey guys, it's Joshua from the future here. So I was just smoke checking this build, and when I plugged in the battery, the video transmitter didn't turn on. And I eventually tracked it down to this problem, which I want to show to you guys. I didn't fake this just happened to me, but it's a great example of what could happen to you. Look what has gone wrong here. Do you see that this leftmost pin here on the ESC it's bent to the side? When I plugged in, it didn't get plugged in quite right, and it got jammed to the side. And now don't worry, it's easy to fix this. What we're going to do is we're going to take a very small flathead screwdriver, is how I prefer to do it. And we're just going to very gently stick it in there and bend it back into position. I think it's going to be hard for me to do here on camera, unfortunately. Let me try and get an angle that's going to work for you. So I've got it bent back roughly straight, but now it's bent downward. Got to try to get in there. I've almost got it. There we go. Perfect. So it's just an easy freaking mistake to make, and I wanted to show you guys that it happened to me, and now you can be careful about that. Next, we're going to get this guy. This is the flight controller, and it is basically the brains of the quadcopter. And the flight controller that Eachine has given us, they very conveniently gave us a whole bunch of plugs so that hopefully we don't have to do too much soldering in order to get this working. Now here's our quadcopter, and remember, here is the front of the quadcopter, and that's where this wire is coming out. It's very important that the flight controller face the right direction. If the flight controller doesn't face the right direction, then when you try to fly, the quad will flip out, because the flight controller will be like, we need to roll to the left, and when it thinks it's rolling to the left, it's really pitching forward or whatever, because it's not turned the right way. And it gets super confused. And so what we're going to do is we're going to look at this arrow right here, this front-facing arrow, and we've got the USB port as well. The front-facing arrow is going to face front, and the USB is going to be on the left. That front-facing arrow is going to be true for every flight controller you work with. They're all going to have a front-facing arrow, and usually the USB is going to be on the left, but in case you can't assume that every time. We're going to take this plug, and we're going to plug it in here to this plug on the front of the flight controller. And if you look real closely, you can see it's labeled S1234, signal 1234. That is the motor outputs. And that is, well, when you do this enough times, you start to recognize those things, but that's how I know that's where that's supposed to go. And what I'd like to do is just give this a few twists to take a little bit of slack out of this wire. Or maybe even just like tuck the wire. Oh yeah, that's good. We'll just tuck the wire under out of the way in a little U shape to get it out of the way here. And we'll set that flight controller down. Make sure you don't pinch those wires as you tuck them under, but you just kind of tuck them in like that. That's going to keep them out of the way. Oh, I like that a lot. I like that a lot. We'll just put the flight controller on here, and we'll grab another standoff, and we'll just put that standoff on there to hold everything in place. Next, we're going to get this GPS module out and figure out which of these freaking wires is intended for the GPS module. Well, let's just start by asking ourselves which one plugs in. Oh, that's convenient. Yep, this appears to be the one. It is the only one of these that has a yellow and a green, and it goes black, yellow, green, red on one side, and then over here on the other side, it's got a 6-pin connector, but only 4 wires go into it. And that is going to plug right here in this plug on the flight controller. Oh, I got it upside down. If it doesn't want to go in, just try flipping it over. No. Make sure that none of the pins are bent. So there's our GPS is plugged in. Very nice. This is the video transmitter. This is going to take the signal from the camera and transmit it to your goggles over the air. And again, they have given us a very convenient plug that we can use to set this up. All right, well, I've just discovered something kind of shocking that they've done. So if you look at the plug for the VTX, they've given us wires for video and power. So it's 7 to 24 volt and ground. And there's another pin here called data, and that pin is very, very important. So when you've got a video transmitter like this, you're gonna remember old analog television channels that would broadcast on a certain channel, and you would tune your television into the channel. Well, that's what you're doing with your goggles. You're gonna put this on a certain channel, and it's gonna have a certain output power, and you may need to change channels over time, especially if you fly with friends. One of them may be using a channel. You have to change to a different channel so you don't stomp on them and transmit over the top of them. That's freaking annoying to do because you got this button here. You got this stupid freaking button, and you got to like hold the button down and blah, 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 blah. Well, it turns out that your flight controller can change the channel and the output power on this video transmitter. You can just look in your goggles and use your transmitter sticks and basically change that stuff without ever touching the quad. And that is just a must-have feature. As soon as it got invented, any quad that didn't have it was just like, forget it. It's so freaking dumb. I don't understand what they've done here, because the video transmitter supports that function. That's what the data pin is. The flight controller has a corresponding pin, but they have, for some stupid reason, left the wire out of the wire harness, so you can't use that function. And like, I've looked to see if there's like another wire harness here that I'm overlooking. No. So I'm going to fix that. You want that. And here's how I'm going to fix that. This right here is an SH 1.0 cable set. I'll put a link to it down in the video description, and you can use it to make your own plugs like this. Now, I'm not actually going to make a whole new plug, but I'm just going to take a wire. I'll have to find a wire of approximately the right length. This little pin has a little downward sticking part, and then there's, you can just barely see, there's a little kind of a tooth that sticks up here, and that's the retention tab. This downward part here is what grabs onto the wire. This little, you can barely see it, that part is the retention tab. And these, see here, we've got these tabs here, and those retention tabs engage with that little tooth. So let me look and see exactly where we need to stick this. So here's the plug that they gave us, and there's another empty hole here just to the outside of the yellow, and that's where our new wire is going to be. We're going to insert that. It's going to be hard to do this on camera. We're going to hold it with that little tooth facing up and stick it in here. There we go, I got it. And it should, see, it doesn't want to slide the rest of the way in. I'm going to take this fine tipped, be very careful not to damage the wire, but I'm going to just kind of press it the rest of the way in very carefully. And then maybe kind of wiggle that a little bit so it engages. Let's try it again. Okay, now it's, yeah, now it's, so it's properly inserted. It won't come out. All right, I'm going to do that same thing on the other side. So now I've added another wire to this plug. I don't know why they didn't ship it that way. It's so, there's no good reason for them not to have shipped it this way. You should definitely do this, even though it's annoying that you got to buy that kit, but you should definitely do this. You do not want to have a quadcopter that doesn't have, it's called smart audio, is the remote control ability for the video transmitter. You want that. You do, trust me. Nobody wants to be pushing buttons to change channels. Why? It's one wire. What the hell? I almost wonder if that's a mistake. It's just so weird that they left it out. Anyway, that's going to get plugged in here. Just like so. Boom, just like that. And we are making progress. Next we've got the camera, and there's one cable left that we haven't used. The camera is going to get... Yeah, okay. So we've got this plug here. It's got 5 pins, but only 3 wires. And it's going to get plugged into the camera. That is going to go right here on the quad. Well, this thing goes together so freaking easy, I can't believe it. Put the rest of these standoffs on. Oh, but not this one. We got some soldering to do here, unfortunately. Now we come to one of the more frustrating parts of building a quadcopter, and that is installing the receiver. And the reason it's frustrating is because there are 2 different types of receiver protocols that you might be using. There are standard receiver protocols, and those include FlySky, iBus, if you have a FlySky transmitter with an iBus protocol receiver. If you have a Spectrum transmitter using DSM whatever, that's a standard. If you're doing Crossfire, probably not doing Crossfire on your first, but hey, who knows, maybe you are. Those are all standard serial protocols. And then over here on the other side, there is FreeSky with their SBus protocol. And the problem is that SBus has a thing called inversion. It is an inverted serial protocol. And basically, you have to tell the flight controller whether the protocol is inverted or not, or it doesn't know what to do. It doesn't know how to read it. So here's what they want you to do. Do you see this plug here is where the receiver would get plugged in? You would use this wire, it would plug in, and it would plug into the pins on your receiver. Well, there's a couple problems with this. One is that you have to tell the flight controller whether you're using SBus or not, and you're going to do that. You're not. I'm going to show you another way, but they want you to do that by solder bridging these tiny pads. They want, I'll do it for you. You'll see. First, I'm going to take off this big honkin' tip from my soldering iron and put on my teeny weeny tip. Then I'm going to heat my soldering iron to its lowest temperature because these teeny tiny pads are easy to damage. And basically, I'm going to try to just kind of heat both of the pads at once, which even with my tiniest soldering iron tip, I mean, they come smaller than this, but I'm going to heat both pads at once and put solder blob so it bridges between the 2 pads. Let's see how I do. Boom. That is how you would do it. And you can see there I've bridged the center pad to the left, which you can kind of see here is labeled SBus. And here on the right, they've got all the others, because SBus is inverted and every freaking buddy else in the world is not. So we've told it now that what's plugged into here is going to be an SBus receiver. I think that a lot of beginners are going to struggle to do that solder bridge, and you may lift a pad or you may damage it. So here's what we're going to do instead. We're going to actually flip this over. I've taken the standoffs off, and I'm just going to put it upside down on the standoff so I can see what I'm doing. And right here, there are individual solder pads where we can solder the wires. And these are a little bit easier. They're a little bit bigger and easier to solder to than those tiny little solder pads. And we're just going to tell it what protocol we're using by choosing the correct solder pad. So if we're using a FreeSky receiver with SBus protocol, you can see that is this pad here is where we're going to solder the signal wire. If we're using any other receiver like iBus or Spectrum, where here is RX2, that's this pad, and we're going to solder to that one. SBus, everybody else. So here's the receiver I'm going to be using for this build. This is the Jumper R1. It is a FreeSky SBus compatible receiver, and you can see here we've got, actually I'm going to do telemetry as well. So I'm going to switch to this pin out because it has bare wires that we can solder on. And here's how we're going to do this. Ground, the black wire, is going to go to ground. VCC, the red wire, is going to go to 5 volts. S bus is going to go to S bus, and then I'm also going to set up smart port telemetry. Heck, maybe RSSI output. Cool. We're going to solder these up. I'm going to tin these wires. The way I'm going to tin the wires is to just set my soldering iron down on the table, and then for each of the bare wires I'm just going to get a little solder on the iron and then get a little solder on the wire. This is actually a silicone baking sheet. They make it, you can find them on Amazon, like pastry sheet, and I've just cut a little section of it. The silicone, when the solder drips, it won't damage my work surface. You'll see also here we've got a 3.3 volt and a 4.5 volt or 5 volt. The 3.3 volt is going to be for some Spectrum receivers need 3.3 volt input. The newer Spectrum receivers all take 5 volts, but the older Spectrum receivers, some of them need 3.3 volts. You may need to look up in your, if you have Spectrum, in your receiver specs, which input voltage it can take. If you're using any other receiver other than a Spectrum receiver, it's definitely going to be 4.5 volts for you. And these two are ground. I don't know why they've given us 2 ground pads, but okay. I'm going to tin the pads that I want to use. So we're going to take ground. Oh, come on. There we go. 4.5 volts and S bus, just like so. We're just going to take the wire and hold it in place and solder it ground. 5 volts. Which one's S bus? I gotta check. S bus is the white one. S bus. Oh, there we go. Okay. The next thing we're going to deal with is a thing called smart port. And smart port is an example of a function called telemetry. Telemetry means that the flight controller can send data back to the transmitter, back to your controller. And so, for example, when your battery voltage gets low, your controller could be set up to say, battery voltage low. There are other reasons why telemetry is useful to have, especially if you're going to be doing like a GPS-enabled quad like this. So I'm going to set up smart port. We're going to solder it to TX5. Okay. And then finally, we've got RSSI output. For now, this receiver has RSSI output. RSSI means signal strength. You know, just like your cell phone has 5 bars, 4 bars, 3 bars. Well, RSSI is a way that you can know how strong your control link is and know when you're about to fail safe, and that's certainly a good thing to know. There are ways to get RSSI readout if your receiver doesn't have it. There are ways to work around that, but since this receiver has RSSI readout, let's see if this flight controller has an RSSI input pad and see if we can use that. And sure enough, it does right here, RSSI right next to this TX2 pad. So we'll go ahead and connect the green RSSI wire to that. Most of you who are following along, unless you're using this exact receiver, most of you are not going to do that because your receiver probably doesn't have RSSI output. Most of them don't these days. See how that's not smooth? It's got a little sticky uppy peak. That is not a good joint. It'll be good. Let's try this again. There we go. That's better. Flux is the key to good solder joints. Okay, that's done. Fantastic. Then, let's see. The video transmitter was such a long wire. The video transmitter is going to go with this. This is called an MMCX connector, and that's going to be facing out the back. Let's see if we can just kind of curl this wire up on the inside here and like just do like that. Yeah, that'll do. Let's get that wire out of the way. And then that's the last thing where it's going to go on. We're going to take these nylon nuts, and does it go sideways? Does it go sideways? It must go sideways so you can get at the button. Yeah, that makes too much sense to not be right. It must go sideways so you can reach the button, but we're not going to be using the button anyway, but yeah, we'll do it that way. Sideways. MMCX connector out the side. Sure. If you didn't set up smart audio by installing that extra wire in the video transmitter plug, then you definitely are going to want to make sure that you can easily get at that button to change channels. So this is the part where I would probably smoke check it. There's an important thing to do before we smoke check it though, and that is we're going to need to install the antenna. Never power up your video transmitter without your antenna installed. So we're just going to, the MMCX just kind of snaps in there with a little bit of force. It may be a little more force than you expect, but it just snaps in there. And then we got an antenna here, and we're just going to install that antenna. That's what we want. Now you might think at this point that the next thing to do, we're so close to done, that you would want to finish assembling the quadcopter, but actually I wouldn't do that, because like, what if we screwed something up, right? I would actually smoke check this and do my function check and actually do some configuration in Betaflight just to check that everything's working before I finish buttoning it up. So that's what we're going to do in the next video. I know I'm leaving you on a cliffhanger, but it's almost midnight here, so it's time for me to wrap it up. Links to all of this stuff are down in the video description. Both the Tyro 119, if you intend to follow along, and any of the extra stuff that I've got, like that wire set and other handy dandy stuff. Links also to this playlist. All the videos in this playlist from start to finish, they're linked down. Well, the whole playlist is linked in the video description. Thank you so much for watching. I am so honored that so many people choose to make my tutorial their first build. I hope that it's been easy for you to follow along. If you have any questions, by all means, put them down in the comments, okay? Depending on how long it's been, YouTube doesn't always show me comments on old videos. You can also just message me. You can message me on Facebook with questions. I'm happy to do it. I spend 2 or 3 hours a day answering questions from people. It really is a privilege. And if you have questions and I don't get to you on YouTube, by all means, contact me on Facebook Messenger. Yeah, that's going to do it for this video. Looking forward to part 2. See you there. Happy flying. Not ready for happy flying yet. We can't fly this yet, but soon. Happy flying, everybody.